Okay. Good morning, students. I hope you are all fine. Stay home, stay healthy. God bless you. Okay, students. Today we are going to discuss about grade 9 physics chapter number 9 motion topic. Okay. Already we have discussed in motion lesson what is mean by motion. That we have discussed. What is mean by motion? An object moves with respect to time and with respect to reference point. That is called the motion. Or an object moving one place to another place. An object moving one place to another place with respect to time and with respect to any reference point. Okay, that is called the motion. Are you clear? Next, what is mean by distance? What is mean by displacement? And what is mean by speed? What is mean by velocity, acceleration? Also, we have discussed in previous class. Okay, am I correct? Okay, students. Here, today we are going to discuss about it's an important topic. It's a very important question. Equations of uniformly accelerated motion. Are you clear? Are you understand the question? Equations. Some equations is there. Okay. How will they form uniformly accelerated motion? Equations of. Okay. Equations of uniformly accelerated motion. Are you clear? Are you understand the question? See here. Uniformly, whenever an object uniformly accelerated means we get some equations. Are you clear? Okay. See here. What is mean by uniformly accelerated motion? What is mean by uniformly accelerated motion? Already we know very well. Accelerated. What is mean by acceleration? The rate of change of velocity is called the acceleration. What is mean by acceleration? The rate of change of velocity. Rate of change of velocity is called the acceleration. Okay. What is mean by uniform acceleration? What is mean by uniform acceleration means equal amount of velocity. We will give equal amount of velocity in equal intervals of time. Okay, now see here, let us consider the one object. Okay, see here, let us consider the car. Okay, now the car starting from here to here. Okay, first 0 seconds. See here, this is the initial point of an object. This is here, a car is starting at rest. A car is starting at rest. Now, the car starts moving. The car starts moving here to here. First seconds, first t equal to 1 second. The car moving 2 meters. Are you clear? Next, the car moves t equal to 2 seconds and this car moving 4 meters. Then next third second, the car moving 6 meters. I understand. This is the object. That is considered a car, a bus, a train. Are you clear? Okay. That is the object. And let us consider the body. Okay. A car moving starting at rest. Whenever we apply the object, whenever we start the car, first t equal to 1 second, a car moving 2 meters. Next 2 seconds, a car moving 4 meters. Next 3 seconds, a car moving 6 meters. Okay, here equal amount of velocity. A car moving equal amount of velocity. Equal amount of velocity in equal intervals of time. This is called the uniform accelerated motion. Are you clear? Whenever an object moving equal amount of velocity, equal intervals of time, at the time that car contains a uniform accelerated motion. Are you clear? Uniform accelerated motion. Then, okay, so this here, that object contains a three equations. Okay, whenever an object is going to equal intervals of velocity, equal intervals of time, that object, that car contains a three types of equations. Are you clear? That is the question. Equations of uniformly accelerated motion. What is uniformly accelerated motion? It is nothing but equal intervals of velocity, equal intervals of time, equal intervals of velocity, equal intervals of time. Whenever we apply the equal intervals of time, equal intervals of velocity, okay, we apply the object. Okay, we give the equal intervals of velocity, equal intervals of time. That object contains here, that car contains here uniformly accelerated motion. Uniformly accelerated motion. Are you clear? Okay. Uniformly accelerated motion. Whenever an object is going to uniformly accelerated motion means that object contains here three equations. What is that? Three equations. What is the three equations? Are you clear the uniformly accelerated motion, students? What is the uniformly accelerated motion? Velocity and time. Equal intervals of velocity. Equal intervals of velocity. Are you clear? What is that? Equal intervals of velocity, equal intervals of time. That is called the uniform accelerated motion. Okay. Okay, see here. The car contains a uniform accelerated motion means the car contains a three type of equations. What are the three type of equations means? What are the three types of equations means? Which is nothing but V equal to U plus AT. V equal to U plus AT. Second equation, S equal to UT plus of AT square. Okay. What is the third equation? V square equal to U square plus 2AS. Are you clear? Okay, see students. An object contains a uniformly accelerated motion. Okay, are you clear? This uniform accelerated motion means increase the velocity of an object, or decrease the velocity of an object. That is also uniformly accelerated motion. Are you clear? Okay. Suppose the car moving, first 2 seconds increase the velocity. Okay, ma? Suppose we decrease the velocity also. First second, velocity 0, t equal to 0, p equal to 0. Next, t equal to 2 seconds means b equal to 5 meter. Okay, ma? 4 seconds equal to 10 meter. Next, we applying the brake on the object. We apply the brake in the car. What happened? Decrease the velocity. Decrease the velocity means 10 meter, 8 meter and 6 meter. Wait, the time interval is the same. 2 seconds, 4 seconds, 6 seconds, 8 seconds and 10 seconds. Okay, ma? This also uniformly accelerated motion. Are you understand? Increase the velocity or decrease the velocity. That is the equal amount of velocity. That is called the uniformly accelerated motion. Are you clear? Okay. Whenever we apply the equal amount of velocity and equal intervals of time, that is called the uniformly accelerated motion. Are you clear? Okay. What are the three type of equations? First equation, V equal to U plus AT. Okay, what is the first equation? V equal to U plus AT. What is the second equation? S equal to UT plus of AT square. What is the third equation? V square equal to U square plus 2AS. Okay, are you clear? Okay. What is the first equation? V equal to U plus AT. What is the equation? V equal to U plus AT. after. Next, s equal to ut plus of at square. Third equation, b squared equal to u squared plus 2as. The three equations are very important. Are you clear? Okay, now we are going to discuss about one by one. Okay, now commonly the three equations, what are present here? Okay, v. What is mean by v? What is mean by u? What is mean by a? What is mean by t? Okay, okay. You have done wrong. What is mean by yes? See here, let us consider that one object. Let us consider that car. Okay. Now the car moving starting from here to there. Okay. We apply the velocity to the car. We apply the velocity to the car. Starting the time t equal to 0. Initial velocity equal to 0. What is mean by initial velocity means starting velocity, that is called the u. Okay, that meaning what is initial velocity? We also call the u. Initial velocity u equal to 0. Now we apply to increase the velocity. Whenever t equal to 2 seconds means we increase the velocity 5 meter. Next t equal to 4 seconds 10 meter. Okay, increase the velocity. See here, u is the initial velocity of the object. This is the car. Initial velocity of the car u equal to 0. Then we increase the velocity. T equal to 2 seconds. The car is moving. T equal to 2 seconds means the velocity is 5 meter. And t equal to 4 seconds means the velocity is 10 meter. Then t equal to 6 seconds increase the velocity. Now the car is stopped. Okay, the car has stopped. This is the final velocity. 10 t equal to 6, t equal to 6 seconds, t equal to 8 seconds, 12 meter and 14 meter. This is the final time. The car has stopped. The car has stopped. Now here v equal to what is the velocity? Okay, are you understand? Do you know the formula of velocity? What is the formula of velocity? Velocity equal to distance by time. Are you clear? What is the velocity of the car here? Velocity equal to, how will you find out the velocity? Velocity equal to distance by time. We use the formula and we calculate the velocity. Okay, this is the final velocity of the object. Here final velocity equal to 14 meter. What is the time? T equal to 8 seconds. Okay, then we calculate the velocity of the car. Okay, are you clear? Okay, now, so here what is mean by u means final velocity of the object. What is mean by v here? I understand. What is mean by u? U is the initial. Let us consider the car. Okay, this is the whenever the car starts the starting point, that is the initial velocity of the car. Here final velocity of the car. Whenever the car was stopping, that is the final velocity. Whenever the car is starting, that is the initial velocity of the object. Here this is the initial velocity. This is the final velocity of the object. Are you understand? Here initial velocity. What acceleration? Abhinavi velocity. Are you clear? Okay. That is that. This is initial velocity of the car, of the object. Okay. This is the final velocity of the car. Final velocity of the car. Final velocity is here. Here to here. This is the initial velocity of the car. This is the final velocity of the car. Are you clear? So what is mean by u? U is which is nothing but initial velocity of the object. Initial velocity of the object or body. Okay, are you clear? Let us consider that one car is going to one place to another one place. Whenever the car starting point, that is called the initial velocity. Are you clear? Okay. Now, what is mean by V? V is the final velocity of the object. Final velocity of the object. Okay. Next, what is mean by A? A is the, do you know very well, what is mean by A? Acceleration of the object. Acceleration of the object. Okay, are you clear? Do you know the acceleration? Increase the velocity or decrease the velocity. First, we increase the velocity. U equal to 0, T equal to 0. Okay, first the car moving, starting at rest. Starting at rest means initial velocity U equal to 0. Next, T equal to 3 seconds. A car moving 5 meters. Okay, T equal to, whenever the car starting at rest, U equal to 0. Okay, ma? Next, T equal to, whenever T equal to 3 seconds means a car moving 5 meters. Okay. Next, T equal to 6 seconds, car moving 7 meters. Okay. Next, we apply the brake on the car. We apply the brake on the car. Okay, ma? Now we are going to Namakkal. We increase the speed same level. Okay, like that. T equal to 3 seconds. Whenever T equal to 3 seconds, we are moving 5 meters. T equal to 6 seconds, we are moving 7 meters. Now we apply the brake on the car. We apply the brake on the car. What happened? What happened? Decrease the speed of the car. T equal to 8 seconds. The car moving 6 meters. And T equal to 10 seconds is equal to 4 meters. In decrease 12 seconds 2 meters. Okay, ma? Okay, that is the acceleration. Acceleration means increase the velocity or decrease the velocity. Okay, increase the velocity of object or decrease the velocity of object. That is called the acceleration. Okay, velocity constant that is the acceleration equal to 0. Are you clear? Okay, see here, that is the acceleration. Acceleration is the rate of change of velocity, the acceleration. But here A equal to acceleration of the object. Are you clear? Okay, now what is mean by T? We know very well T, time interval of the object. Time T equal to time interval of the object. Okay? Okay. Next. This is the first equation. You know very well what is mean by U. What is mean by U? Initial velocity of the object. Okay. What is mean by V? Final velocity of the object. What is mean by A? Acceleration of the object. Okay. What is mean by T? T is the time interval of the object. Are you clear? Okay. Next equation. Yes. What is mean by yes? What is mean by yes? Any idea? That is the displacement. Already we have discussed what is mean by yes. Yes is the displacement of the object. Are you clear? Okay. A car moving here to here. Okay. This is initial point. Initial velocity. This is the final point. Okay. How much distance or displacement? That is called the yes. Displacement of the object. Okay, here what is mean by S? S is the displacement of the object. Displacement of the object. Let us consider now how much distance. Okay, a bus starting from Trinity School to Namakkal. Are you clear? Okay, what is that is the S is the displacement of the object. Example, now our Trinity School bus Trinity School to Namakkal bus stand. Okay. How much distance traveled by a bus? Okay. That is the displacement. That is the displacement. That is for the yes. S is the displacement of the object. Okay. Here car. This is the car. Here Trinity School. Here to Namakkal bus stand. Okay. How much distance covered by the bus? Are you clear? That is the displacement of the object. Are you clear? Okay. That is the S equals first equation. Clear now? Okay. What is the first equation? V equal to U plus AT. V means final velocity of the object. U is the initial velocity of the object. A is the acceleration. T is the time interval. In second equation, S, what is mean by S means distance, displacement or distance of the object. Are you clear? This is the Trinity School. This is the Namakkal bus stand. Okay. A car, how much distance? A car covered by the distance. A car covered how much distance? Are you clear? A car covered how much distance? That is the displacement. Okay? Okay. Now, third equation, V squared equal to U squared plus 2A. Yes. You know very well, all the one is here. Okay, ma? Okay. Now, we are going to discuss about equation 1 by 1. Okay, okay, students. The three equations, okay, ma? The three equations is equations of uniformly accelerated motion. I have explained how we come these equations. Okay, ma? Whenever an object moving uniform accelerated motion means an object contains here three equations. Are you clear? V equal to U plus AT. This and second is the S equal to UT plus of AT squared. Third equation V squared equal to U squared plus 2AS. Okay, are you clear? Okay, see here. The first equation relation between which one and which one? Okay, the first equation relation between what are present here? Velocity and time. Are you clear? Acceleration, we know acceleration is rate of change of velocity also acceleration. So also velocity. Are you clear? Okay. The first equation relation between which one and which one? Velocity. If this is the final velocity of the object, V is the final velocity of the object, U is the initial velocity of the object, A is the acceleration, T is the time. So, we conclude that what is the first equation? What is the relation between the first equation? The relation between the first equation, relation between velocity and time. Velocity and time. Are you clear? The first equation relation between velocity and time. Are you clear, students? Do you know very well? V is the final velocity of the object. U is the initial velocity of the object. Are you clear? Okay. Now we are going to second one. Second equation relation between which one and which one? What is meant by yes? Okay. Displacement of the object. Okay. What is meant by U? Initial velocity. What is meant by A? Acceleration. Also velocity. T is the time. What are present here? Displacement and time. Are you clear? Displacement and time. Okay, ma? Okay. Second equation relation between but here we calculate the distance. Here we calculate the final velocity. So relation between velocity and time. Here relation between distance and time. Are you clear? Okay, relation between distance and time. This relation between distance and time. Are you clear, students? Don't confuse that. Okay, ma? What is the first equation? V equal to U plus AT. What is the second equation? S equal to UT plus of AT squared. Are you clear? So, here we calculate distance. will give many numericals. Okay, so we want to calculate the distance. We want to calculate the final velocity. We want to calculate the initial velocity. So we want to use this equations. Then we calculate the displacement of the object, final velocity of the object, initial velocity of the object. Are you clear? Okay, see here. Next, third equation. What is the third equation? V squared equal to U squared plus 2AS. Okay. What are the present here? This equation, do you know very well? You know very well. Velocity. V is the final velocity of the object. U is the final velocity of the object. A is the acceleration, and S is the displacement or distance of the object. Okay, ma? Okay. Okay, see here, what is the acceleration? Which is nothing but increase the velocity or decrease the velocity. That is called the acceleration. Where the rate of change of velocity is called the acceleration. Okay, so don't confuse that. Okay, okay, see here, this equation relation between what are not present here? Velocity and distance only. So we can write easily relation between this velocity and displacement. This third equation, relation between velocity and displacement. Velocity and displacement. Are you clear, students? Okay. Whenever an object moving uniform accelerated motion, at that time, that object contains here three equations. Do you know very well uniformly accelerated motion? Increase the velocity, equal amount of increase the velocity or equal amount of decrease the velocity of the object. That is called the uniformly accelerated motion. Are you clear? Okay. Now we are going to discuss about one by one. Okay. How did come these three equations? Okay, students. Okay, now we are going to discuss about okay. Now we are going to derive first equation. Now we are going to derive first equation. What is the first equation? V equal to U plus AT. Relation between velocity and time. Okay, ma? Okay. Let us consider the one object. Okay. Let us consider the one object means let us consider the one ball. Okay. This is now the ball leave from my hand. Okay, what happened? The ball leave from my hand. What happened? Is going to reach the ground. Okay, why means gravitational force. Okay, see here. This is the initial velocity of the object. This is the initial velocity. U equal to 0. Now the ball is moving to increase the velocity. Whenever I am going to leave the ball going to increase the speed. Okay, increase the velocity to attain the final velocity. Are you clear? Whenever we leave the ball from my hand is going to find the initial velocity to reach the final velocity. This is the initial velocity. This is the final velocity. Are you understand? With the time interval, increase the speed or increase the velocity. Are you clear? Okay. So here now we can write U is the an object contains the initial velocity. Consider a ball. Let us consider the ball. Let us consider an object. Let us consider any one object. Now we consider a ball. Okay. Let us consider a ball. This is the initial velocity of the ball. Okay. What is the initial velocity here? U is the initial velocity. Initial velocity of the object. Okay. V is the final velocity of the object. Next, A is the acceleration. Okay, whenever we leave the ball, first increase the velocity. Okay, time interval, the same equal amount of velocity, equal intervals of time. That is the uniformly accelerated motion. Okay, see here. We leave the ball from my hand. What happened is going to reach the ground. Okay, okay, so uniform acceleration. Are you clear? This is the uniform acceleration. The rate of change of velocity is called the uniform acceleration. Okay, next T is the time interval. T is the time interval. Okay, now we derive the equation from the definitions of acceleration. Why we take the acceleration? The rate of change of velocity, that is called the uniformly accelerated motion. Okay, so here v equal to u plus 4 at. Okay, are you clear? This is the, let us consider the ball and this is the rate of change of velocity. So we calculate the acceleration. So we derive the equation from definition of acceleration. From the definitions of acceleration. Okay, what is the formula of acceleration? A equal to acceleration. What is the formula of acceleration? Acceleration equal to change in velocity by time taken. Change in velocity by time taken. Okay. What is the change in velocity? Acceleration we can say A. Change in velocity means final velocity to initial velocity. This is the initial velocity to final velocity. Okay, change in velocity, final velocity to initial velocity. Here u equal to 0. Here final velocity v equal to something is there. Okay, okay. Here final velocity minus initial velocity by time taken. Okay. Okay. What is the final velocity? Acceleration A equal to, what is the final velocity? We can say v, small v. For initial velocity we can say u. Okay. Now time taken t. Are you clear? Okay. See here. What is mean by so we derive this equation, no? Okay. How will you derive? AT. The t comes this side. AT equal to v minus u. Are you clear? AT equal to v minus u. Here A t plus u come this side, minus u come that side, plus u. Minus u equal to this side plus u. AT plus u equal to v. Okay, this equation have been derived. Okay, so we can write v equal to u plus ut. Okay, are you clear? V equal to u plus ut. The first equation have been derived. Are you clear, students? What is the first equation? Relation between velocity and time. Okay, students, are you clear? Okay, now we are going to once again I will explain. See here, what is the first equation? V equal to u plus at. What is the relation? Velocity and time. Okay, now let us consider an object. Now we are going to we take a ball. Okay, this is the initial velocity of the ball. This is the final velocity of the ball. This is the time interval. Are you clear? Time interval. This is the distance also. Okay, within the ball moving one place to another one place with respect time. This is the displacement. A ball moving initial velocity to final velocity. That is the displacement. Okay, are you clear? Okay, let us consider the one object. That is the example. Let us consider the example. We will take the ball. Are you clear? Okay. Now let us consider an object. Object is a ball. Next, u is the initial velocity of the object. Here, this is the initial velocity of the object. Here, the object is at rest. Okay, so what is the initial velocity of the ball? U equal to 0. Okay, now the ball at rest. Here, the initial velocity U equal to 0. Are you clear? Now, we will remove the ball. Okay, we leave the ball from my hand. We leave the ball from my hand. What happened? The ball is going to reach the ground. That is the final velocity of the object. What is the time interval? Okay, the ball here to there moving. What is the time interval of the object? This is the final velocity. V equal to what is that? That only we calculate. Are you clear? This is the initial velocity. This is the final velocity. What is the time interval? What is the displacement? Are you clear? Okay. An object is going to an accelerated motion. Okay, are you clear? Okay, see here, u is the initial velocity of the object, v is the final velocity of the object, a is the acceleration. Okay, acceleration, do we know the rate of change of velocity? Okay, t is the time interval of the object. Okay, this equation, suppose this object is going to uniformly accelerated motion means we can derive the equation from the acceleration definition. Okay, are you clear? It's a very important key point. An object is moving uniformly accelerated motion means we can derive this equation, first equations of motion from the definitions of acceleration. What is the acceleration formula? Acceleration equal to the rate of change of velocity by time taken. We know very well. Okay, ma? What is the rate of change of velocity? Equal intervals of time, equal intervals of velocity, equal intervals of time. Are you clear? Okay. Now, acceleration, we can say A. Okay. Next, change in velocity means final velocity to initial velocity. That is the rate of change of velocity. Okay, ma? Initial velocity and the final velocity. That is the change of velocity. What is the formula? The rate of change of velocity means final velocity to initial velocity. This is the final velocity. This is the initial velocity of the object. Okay. Now, time taken. What is the time interval of the object? From initial velocity, initial to final. Okay, ma? See here. A equal to final velocity, we can say B. Initial velocity, we can say U. Time taken, we can say T. Okay. Now, are you clear this point? Okay. Now, the T come this side. This is the denominator T. This equal denominator. The T are present in denominator right side. Now we come the T comes from left side means denominator division. Okay, the T are present in denominator division T means whenever the right side left side comes means in multiplication. Okay, the denominator division right side left side is multiplication. Are you clear? AT equal to B minus U. Okay, what is the equation here? V equal to U plus AT. So we can change this equation. AT minus U come that side, minus U come that side means plus U. Okay, ma? Check. AT plus U equal to B. We can write B equal to U plus AT. So first equation we have explained. Are you clear, students? Okay. What is the first equation relation? Relation between velocity and time. Okay, students. Thank you. I hope you have understood. Okay, students. Thank you. Next class, second equation and third equation we will explain. We will explain also numericals also. We will explain. To practice this equation in your home. Okay, students. Thank you.